Hey, good day, guys. You're welcome again to my channel. I am Joshua, the designer. All right, today I want to be discussing with you how to apply wind load to your structure using Prota structure. And wind load is something we should not ignore when we are designing our structure, particularly when it gets to certain height. And considering the IS code 875 in particular part 3 2015, it says that when the height of the structure exceed or from 10 meter and above, we need to begin to consider the wind effect, the wind load. Of course, we know that the wind load is one of the horizontal loads that has influence upon our structure, and it is very important that we consider that. And in this video, that is exactly what I'm going to be showing to you in very very simple way. All right, so in case you're joining my video, you're coming around my channel for the very first time, I am Joshua, the designer. I make amazing content around structural engineering, and you'd want to do well to like this video and subscribe to this channel so that you can get glued to contents that get you better in structural engineering. All right, straight into how we go about the wind load in product structure. All right, this structure you're seeing right here is a high-rise building, obviously. 11-story building, about 35-meter high. Of course, like I said before, when the structure exceeds 10 meter, we need to begin to place consideration on the wind effect, the wind load, and that is exactly what we want to do here. So this is a 11-story building on a pied raft. All right, as you can see here, this is a pied raft foundation. All right, so we want to apply the wind load on this. Okay, having done all this model and all of that, we want to get down to our building analysis, and this is where we actually make certain settings, put in certain parameters that could influence our designs, and we run our analysis again. All right, so you get to the loading combinations. These are default loading combinations, as you can see, dead plus live and all of those things. All right, but there is one loading combination, one consideration that we are not putting into this yet, and that we will need to put in if we want to apply the wind load. And that is to say that you are going to get to your loading generator, which is this loading generator. Now this is a pop-up box here. We have the vertical load combination, and those are such represented in the previous dialogue that we showed before we got here. All right, then we have the horizontal load. I told you that wind effect is part of the horizontal load because the wind takes effect horizontally. All right, and we have certain degrees with which it takes influence. We have the 0 degree, we have the 90 degree, and we'll come to that as we go on. All right, so we have the horizontal load combination, and you come here, you see the wind loading. You see that this wind loading is unticked. What you want to do now is to tick the wind loading, and it activates the combination for wind. You see that we have G plus 1.3 Q plus 1.3 W. We have 0.9 G plus 1.3 W. All right, so we have the wind in the X direction and the Y direction. All right, so we want to, but the code, the code is applying with this wind now is AN1991, that's 1991, 1 to 4 2005, and we can see this here. All right, so we can just use our OK. Once you do that, you see that our wind load combinations have been introduced into the loading combination. All right, so if you do not do that and you go directly to your wind, is going to resist whatever you want to do. It's not going to allow you. Let's see what I'm trying to say here. If I can show you from here. Okay, I want to see if I can really make you see what I'm saying. Okay, so this is it now. We are starting from here. So let's assume I have not done all of those things I previously showed to you. I want to apply my wind directly. So when I come to the wind and story load, Now you see it says cannot find any defined wind load case. Please define wind load case first. All right, and that's what exactly I showed to you first. So I'll go back there and do that again. Loading generator, as I formerly showed to you, horizontal load combination. Then we activate the wind loadings. Then we press OK. All right, so we automatically have all that we need as touching the load cases. Then we use our OK. Now then we can proceed to the wind and story load. Wind and story load. All right, so clicking that wind and story load, you have this. Of course, these are the parameters, or these are um the parameters, like I said, for every story down to the 11 stories. But we are not sure if these are going to be the correct load as correct parameters or values to apply. So we want to calculate it appropriately. So using the wind load calculator now, you have this, because all the parameters you are going to enter into this place would be used in performing the wind uh, load analysis. All right, so with this now you have the basic wind speed, and basic wind speed vary from one region to another, from one place to another. So you may need to consult um, the right authority, the right document that is unique to your region to have this value, because like I said, it varies from place to place, varies from region to region. So you may want to consult the professionals that has to do with that to provide you data in that regard. All right, so for my region, this particular project is on the island. All right, an area exposed to wind. All right, so I will want to stay with 35, and the wind pressure 0.6, which is right. That's what I want to wait for. Now the primary wind angle is 0 degree, and this seems to be the most critical um, influence, the angle of influence, the most critical angle of influence. All right, so I'll stay at 0 degree. Then the terrain and surrounding. Now this hill height that was seen here is basically the height of the hill before the building, or the height of the obstruction close to the building. All right, the next obstruction, because when the wind is coming towards your building, whatever obstruction it meets tends to reduce the wind effect, tends to reduce the rate at which the winds will hit your building directly. So that's the obstruction, that's the hill height. So in real time, it could be hill as hill, the normal hill that we know, and it could be certain buildings that come before that particular building that we are designing, because it takes in regard any obstruction that could influence the rate at which your wind directly hits your building. All right, so for my case here, I have 10 meters away from the building, 10-meter high rather, 10-meter high. The hill height is 10-meter high. All right, so that's because the higher it goes, it means it's covering to an extent the influence of the wind to certain stories, or from certain stories. All right, so the x meters is the distance of that obstruction, or the crest of the obstruction, or the crest of that hill from your building. All right, so the distance between your building and the crest of your obstruction, or the crest of your hill, that's x. And for my own is 12 meters. 12 meters. Now this LD is the actual length of the downward slope in the wind direction. So if you are actually dealing with hail, all right, so you want to get the actual length of the downward slope, that is the original length of that slope. So what you do now is you obtain the longer side, of which you may call, though it's not a straight hypotenuse, all right, for a hill, you get the slope of that slant side, right, you get the vertical up to a datum level. All right, then using the mathematical principle of Pythagoras, you get the actual length of um of the downward slope. Okay, and the same thing you do for LU. All right, LU. All right, once you have this, then you can obtain LU. All right, and the LU, yes, actual length of the upward slope in the wind direction, actual length of the downward slope in the wind direction. So that's LU and LD. So those are my values. I leave them as it is. Now for the ill type, so you want to categorize, or you want to be specific on what that ill represent, that ill type, what it represents. We have cliffs, we have escarpment, we have hills, and we have ridges. So if you I have some pictorial representation of cliffs and escarpment right here, so I'll share with you in case you want to be sure of what I'm talking about. So this is a cliff. Where you see that it has a vertical, somewhat like a vertical surface that can serve as an obstruction or to wind, all right, against your building. All right, so if this is what you have, that's escarpment. All right, I think I have another cliff. This, you see now, this cliff from behind, the wind from behind would literally have little or no effect, maybe let's say little effect on this building, because your wind comes in a direction. It comes in a direction. All right, so I have this. You see, this is a cliff also. Then let me find an escarpment for us. All right, so this is also an escarpment. This is an escarpment. All right, so whatever it is the consideration in your case you may want to put. So for me, I have cliffs and escarpment. All right, we have upwind or downwind. Mine is upwind. All right, so if yours is downwind, you want to apply. All right, because your case might be unique, might be different from mine. So mine is upwind, so you put that as you have. We have C direction one, C season one, terrain category. There are different categories of your terrain of which you must check. So let's click category. The category now is saying category 0, sea or coastal area exposed to the open sea. I told you this project is in the on the highland, all right, where it's open to sea area and all of that. And that's why my own category is category 0. Some other might be category 1, flat area with negligible vegetation and without obstacles. That is, they are just flat, is open to direct influence of wind. Of course, that might be someone's conditions. Category 2, area with low vegetation such as grass and isolated obstacles with separations of at least 20 obstacle lines. You see that. Category 3, area with regular cover of vegetation or buildings or with isolated obstacles with separations of maximum 20 obstacle heights. Category 4, area in which at least 15% of the surface is covered with buildings and their average height exceed 15 meters. So category 0 is my category. So I click that. If yours is category 1, 2, 3, 4, you use appropriate, but this is mine. Okay, then I've applied. Building category. Am I designing a reinforced concrete structure? Am I designing a steel or a composite structure? Or am I designing RC tower or chimney? Alright, but this structure is a reinforced concrete structure, as we can see. Alright, so I use that. When you're done, you can check for your report or an result. Now this is my wind at the critical angle, 0 degree. All right, of course the two angles are critical, but I want to believe 0 degree is more critical in this scenario. All right, so I have at different heights and length, I have the pressures well distributed along different heights. All right, and I have the load in kilonewton, all right, on the structure. At 90 degrees I have this. values. These are the results. So if you do want to print or create report from here, you can do that using this create report. Then you have your reports for your wind. All right. Then you can convert to PDF, or you can transfer to Word document. All right, but and that's all. All right, but now we want to apply all that we have done. We want to apply all that we have done. Just apply. Now I've applied that. Then after applying, I can get to OK, and I'm done with my wind and story load. I can go ahead to my analysis and run my building analysis. All right, so this is exactly how we apply wind load to our structures. Do not forget, as long as your building is exceeding 10 meters, and that is to say that when you're going beyond 3-story building, using an average height of 3.1 meters, then you should consider the wind effect and the wind load appropriately. All right, so if you have any questions, any comments, any queries along this line, you can do well to use the comment section, as I'll be there to answer to every of your queries, every of your questions, every of your comments. And I am Joshua the designer. Do not forget to subscribe to this channel. Share with your friend that should get better in structural engineering. This is where we have amazing contents that get you developed and get you equipped when it comes to structural engineering. Till we meet in the next video, I am Joshua the designer. Bye.